The Maltese Cross Tube uses a hot filament which emits electrons, and the electrons are then accelerated by a high potential difference and hit the screen at the front, giving out light. This light is a green colour, which we can see here, and we get a shadow where the electrons that hit the Maltese cross do not hit the screen, and so that bit doesn't glow. Here I've added an ammeter to measure the current through the cross, and I can use that to calculate the number of electrons flowing per second. We can see from the reading on the meter that the current is 0.41 milliamps, and current is the same as charge per second. Converting the current into amps, we can then calculate the electrons per second by doing the charge per second, or the current, divided by the charge on one electron. Substituting the numbers in, that gives us 2.6 times 10 to the 15 electrons per second, which is really quite a lot. This makes a nice calculation to get A-level students to do when you're teaching about current or about electron guns. To set this up, the first thing that I need to do is connect the low voltage 6.3 volts AC to the filament, and this is shown with the blue wires in my setup. I then need to connect the negative terminal of the high voltage part of the power supply to one of the filament connections as well. I then need to connect the positive terminal of the high voltage part of the power supply to the anode, and I also need to connect that via a milliamp ammeter to the Maltese cross part of the tube. To do this safely, you must use a current limited EHT power supply, but you'll need to connect with the output that doesn't have the extra 50 megaohm resistor in it to provide enough current. Now we can turn on the low voltage supply to light the filament, and we can see that now some light is coming out and is making a shadow of the Maltese cross in light on the end. To accelerate the electrons, we need to put the high potential difference onto the anode and the Maltese cross, and as we increase the potential difference, this being shown in kilovolts, we can see that the electrons are being accelerated faster, hitting the end screen with more kinetic energy and therefore giving out more light. From the increased current reading on the milliamp ammeter, we can clearly see that the number of electrons arriving per second at the Maltese cross is also increasing and decreasing as we increase and decrease the accelerating potential difference. The demonstration is clearer if you turn off the lights in your lab and have it in semi-darkness, and then you can really see the difference between a high and low potential difference accelerating the electrons.